What connects a glow stick and a rusty bike and your breath? It is the same quiet engine called a chemical reaction. Snap a glow stick in the dark, faint light blooms along the tube. You hear a tiny crack as glass breaks inside, two liquids rush together and mix. You shake it and watch the colors spread. Molecules meet and the glow grows. This is not electricity or magic at work. This is atoms changing partners with purpose. Here is the simple idea you can hold. A chemical reaction rearranges atoms into new substances. The starting materials are called reactants. The newly formed substances are called products. Atoms keep their identities through the change, only their bonds and connections shift. Nature keeps a perfect ledger every time. The number of each atom stays the same. A balanced equation tells this bookkeeping story. Coefficients make the counts match exactly. So why do atoms let go and reconnect? The answer lives in energy moving through bonds. Breaking bonds always costs some energy. Forming bonds always pays energy back. If the payback is larger than the cost, the surroundings warm as energy is released. If the cost is larger than the payback, the surroundings cool as energy is absorbed. Your hands feel that energy flow sometimes. Your eyes see it in the glow stick light. Most reactions need a first push to begin. Chemists call that push the activation energy. Picture two valleys with a hill between them. Travelers must climb before they can coast. A match spark lifts wood over the hill. The flame then continues on its own. In the glow stick, the snap supplies the push. Mixing brings partners close enough to react. If you want to lower that hill for travelers, you invite a catalyst to open a lower pass. A catalyst speeds the path without being consumed. It steps aside unharmed when products appear. Inside your cells, enzymes are expert catalysts. They run life's chemistry fast at gentle temperatures. Speed decides how a reaction feels to you. Slow can soothe while fast can destroy. Molecules must collide in the right orientation. Not every bump leads to bonding. Raised temperature and motion increases everywhere. Collisions grow more frequent and more forceful. Increase concentration so partners are packed closer. Encounters become far more likely to succeed. Grind a solid to expose fresh surface. Many new sites become available for contact. Squeeze a gas to increase pressure carefully. Molecules collide more often in tighter spaces. Stir a mixture to refresh contact constantly. Reactants keep finding one another efficiently. Choose a catalyst to guide the pathway. You speed the right steps and avoid the wrong ones. Some reactions are two-way streets by nature. Forward and backward happen at the same time. When the two rates become equal in a system, the overall amounts appear steady and calm. This living balance is called equilibrium. Molecules still dance while totals stay the same. Change temperature or pressure or composition slightly, the system shifts to reduce your push. This predictable shift is Le Chatelier's principle. The balance leans against disturbance to settle again. You can steer outcomes by nudging conditions, direction, and yield, respond to thoughtful control. Names you learn in class help spot patterns. They group similar reaction moves for clarity. Synthesis builds something larger from smaller parts. Decomposition breaks one substance into simpler pieces. Single replacement swaps one partner in a pair. Double replacement swaps partners between two pairs. Acid-base reactions trade protons between species. Redox reactions trade electrons to move charge. Combustion partners fuel with oxygen for release, heat and light, and gases rush outward together. Polymerization links many small repeating units. Long chains become plastics and rubbers and proteins. Once you learn these rules, you see them everywhere. Your home and body and city hum with reactions. Crack a glow stick and watch cold light appear. That chemiluminescence is energy leaving as photons. A steel bike left wet turns reddish-brown. Oxygen takes electrons and rust slowly forms. A coin darkens and then shines after polish. The polishing drives a reverse reaction to clean. Batteries store chemical potential between electrodes. Redox pushes electrons to power your phone. Charging your phone runs the chemistry backward. Unplugging lets it run forward to do work. Inside you, glucose reacts with oxygen every moment. Cells capture that energy to move and think. Hemoglobin grabs oxygen in lungs and lets go in tissues. Binding and release are chemistry on a schedule. Fire warms a campsite on a clear night. Fuel and oxygen combine and energy spills as heat. Photosynthesis fills the world with stored sunlight. Leaves build sugars from carbon dioxide and water. Concrete hardens as minerals react with water. Strong networks grow grain by grain over time. A developing photograph reveals hidden images. Silver compounds transform when light triggers a reaction. Return to the glow stick now with new eyes. The story inside the tube is clear. Two reactant solutions met when you snapped it. Products formed that release energy as visible light. No atoms were created or destroyed in the process. The counts before and after still match. The snap supplied the activation energy you needed. Mixing ensured collisions in the right orientations. The color depends on the specific molecules involved. The rate depends on temperature and concentration. Tie the ideas together like a good roadmap. Think like a curious engineer of atoms in motion. Identify your reactants and products with care. Check atoms are conserved in a balanced equation. Plan where energy must enter or leave the system. Decide whether heat should be added or carried away. Lower barriers with a catalyst when possible, or warm gently to help effective collisions happen. Tune the rate with concentration, surface pressure, and mixing. Guide the pace safely without changing the destination. Watch for equilibrium as a living balance, steer direction, and yield by nudging conditions thoughtfully. Keep safety at the heart of every design choice. Slow, controlled release is wiser than sudden release. Here is the definition one last time for clarity. A chemical reaction rearranges atoms into new substances. Bonds break and bonds form in sequence. Energy shifts while matter is carefully counted. Families of reactions overlap as conditions change. Pathways bend, yet the rules remain dependable. From glow sticks to engines to forests and cities, reactions are the engine of everything becoming something else. If this made the hidden chemistry feel vivid and clear, share it with a curious friend today. Join us for the next deep dive into everyday science. Like and subscribe so we can keep exploring together.